Nice and close to the
Welcome
microphone.
to my talk on the Devouring, the tech overview. I assume everybody here knows what the Devouring is, but if you don't, the Devouring is a 5-hour multiplayer VR horror experience. It was developed by 4 VRChat creators over the span of 10 months. None of us are actual game developers, and I guess sort of recent part on this that it won 2 awards in the Rain Dance Festival. So, kind of unexpected for a VRChat world. But now, what is this talk specifically? Let's move to the next one. Hit double there. So this talk specifically, it's basically an overview of the Devouring from the tech side. Basically, my point of view of what happened in the Devouring as the only programmer on this project. And so, I'm kind of apologizing. There's a lot of content to go over, as it kind of says on the slides. That's like every single topic that I mentioned could have been its own individual talk, and so this is basically 50 talks in one. So gotta move fast. So bear with me. I'm not going to go into super detail on all the things, but I'll still try to go into enough to make sense of it. But for the first part of it, what was the workflow working with 4 people? So as I said, 4 VRChat developers worked on this. Myself, Fiona, Kuza, and Legends, who are actually now on the front row there. We were all working on this project together for 10 months. And so how did we work together? Specifically, we used Unity Collabs. That's basically a built-in version control system inside Unity Editor. So it being in the editor itself made it easier for non-programmers to understand it. But with Unity Collabs, it does have some issues. For one, it does not handle conflicts very well, so we had to accommodate that with a lot of different things. And as kind of said on here is that we had to use separate scenes for a lot of things, as well as just a bunch of different prefabs. So whenever we wanted to work in parallel, we basically could not work on the same thing. We had to divide up the work and say, like, okay, you get that scene, I get this scene, and then just, not work on the same stuff until we, like, release what we were working on. And so as you can see, just some standard Unity interfaces there. Next piece, how did we actually organize ourselves? We basically used Google Docs for some general organization. We made like a design doc like going over different like topics of things, and so if you are building a project, especially collaboratively, use Google Docs, write down your plans and get approval from other people in the project. And then the next step of that is if you are having tasks, do task management, write them down somewhere. Google Docs is pretty easy, it's free for this one. It's probably not the best, but it just worked for our flow. And so as you can see in the picture up here, we basically had task tracking, which was just like, a giant bullet point list. And so inside that, we kind of assigned it to people based on color. And then once we had finished it, we just crossed them out and like moved it to the lower list. Very primitive, but it worked for our situation because in this slide, I also mentioned playtesting. We would just like, while playtesting, we would literally just write out a bug we found in the doc. So it's just kind of, as you found the bugs, you wrote them out. It was just easier to have it all in one place. Continuing other pieces of this, we had a lot of different discussion channels in our Discord. So the 4 of us are in a like private server for Discord, and then we just have our development channel specifically for discussing all the things there. In fact, like that's not even all of our discussion channels. We still had like 4 more just below that weren't listed. And so the last piece there is just playtesting. The beginning of the project overall, like we did not have much playtesting, but once we got to a point where everything was in one scene, then it's like, okay, we got to playtest, bug test, find all the things. And then that ended up being, I think, maybe a playtest every other week. Eventually, towards the end, it became like multiple times per week. It gets kind of tedious because each playtest could be 3 hours long every time. And so that was a lot of time just spent in the Devouring. Listening to Fiona screaming. One other piece on that is that with the Devouring, we actually had external beta testers. Like, throughout the process, nobody knew what we were really building. We did hype it up like in the beginning of October, but we didn't tease anything. And so because of that, we had no idea how people would react. And so in order to understand how somebody would react and see if, our assumptions on what things we assumed people would do were correct, we had to like get private beta testers. We had overall 5 private beta testers, and each time we learned so much that it pretty much took like almost a month between beta testing, just being like, okay, we got to fix this, this, and that. Like, not even just straight bugs, it was also just being like, things were not clear. And so we just had to continually update. And so that is all on how our workflow was. Let's just go into, from my point of view, like what this project is. Like, this was in SDK 2. This was not in Udon. The Devouring started before Udon was released, and kind of sadly released after Udon was, so we didn't have the opportunity to switch. But with SDK 2, there's no custom scripts uploaded with the world. With that means like everything had to be done with VRChat's SDK and things within Unity, which was like UI buttons and not listed there as animators. So people have known me as, I think what Centauri said, I am the trigger abuser. Obviously I talk about UI buttons a lot because that's Unity's version of triggers, but it's just exposing different things. What may not be known is that I also just build editor scripts for everything. So since my second public world, I've pretty much had an editor script to automate my workflow in building stuff. And since I said all of the triggers and things, you don't need to actually read all of that. I'm just going to point out, like at the top here, that we had 4,000 VRC trigger components and then 1,000 UI buttons. Like, this was a massive project. And so, let's see. About myself and work philosophy, thanks to my time in college and specifically with competitive programming, the one thing that I have learned and that everybody should be doing when working on worlds, or really anything, is create a plan. Plan your stuff out before you start. And so what you should really be doing is figure out what the problems that you're trying to solve are, find the requirements, and then, as I'm saying here, divide it up, and then solve each little piece and then combine them together. So because I went through competitive programming, which is obviously a nerd sport, but it was basically a time constraint problem solving activity. You pretty much get 5 hours to solve a massive packet of problems. You get 1 computer and 3 people. And because it's 3 people for 1 computer, you don't want to waste anybody's time. So if you're not on the computer, you are planning how to solve problems, not actually, typing them out as solutions yet. That's just what I learned from college. One of the other things about me specifically is that I really don't like doing tedious things, which is weird because I'll end up doing tedious things in code to do the tedious things for me. So I will automate everything I can, and by doing that for VRChat, it pretty much just means write an editor script for everything. Write an editor script for everything. If it ever plans on being tedious, if it ever is repetitive, I'll just have the computer do it for me. So if I know I have to do it once, most likely I'll have to do it twice. So if I can just automate it, it then just becomes a button click and it's already done. And speaking of editor scripts, let's go into some of the main editor scripts that happened with this project. There's 3 listed here, which were like the biggest contributors to it sped up the development of the Devouring. And the first one, which you've pretty much heard in a couple of other talks already, is CyanEmu. As most of you have known, testing in VRChat World, or testing VRChat Worlds is pretty difficult with the base SDK. You can't, well, for SDK 2, you can't do anything in Unity. You were only able to see what was set up, but you couldn't actually test it. And so if you wanted to test it, you would have to make a build and then upload it to VRChat. Go through your world and then just see, did it work or did it not? If it didn't, well, good luck reading the logs, because that's kind of difficult. I saw this, I thought, yeah, that's not good enough. I'm going to come up with a solution. I need to be able to test in Unity. I need rapid iteration. And so by doing that, I developed CyanEmu. And so what exactly CyanEmu? Testing in Unity, you can just debug things live. The version that is released now supports SDK 2 and Udon, but during the development of the Devouring, it didn't. In fact, CyanEmu, which started back in 2018, is just not as complicated as it was now. Back then, it was just supporting like basic trigger stuff, like nothing complicated, no other SDK components, didn't even have a player controller. Just before the Devouring had started, I realized that I wanted to make more of this, and I made a player controller. And then it's like, wait a minute, this is needed for like larger worlds. So I kept on adding more features during the development of the Devouring as I needed them. One of them being the whole late joiner buffer testing. And here's a quick example of testing the Devouring in Editor. So in this example was the moving shelf. You click the button or click the interact and a shelf would move, and testing in Unity Editor, you can see, well, how did the animator react every time you click the interact? And so from this, it made it super easy to debug animator bugs. And so, honestly, without CyanEmu, we probably would not have made the Devouring, because no, it's not worth testing for 10 months. Like, honestly, we would be still developing it now if we didn't have this. One of the next editor scripts, which honestly I don't talk about, or have not really talked about, is something I called the label linker. So with SDK2, you need to manually link or reference every single object you ever want to interact with. That's kind of tedious, especially if you have a prefab or something just kind of like wanting to mess with multiple objects all over the scene. And another example of like what this is a problem is if you wanted to update, say, like a prefab, you will then have to manually update every single instance of the prefab that references something outside of it. I saw this and thinking, like, this is going to be tedious. I don't want to do this every single time, so why not automate the system? And so I created a generic framework, or at least for myself, that is a way of marking special objects using labels and then automatically creating references between the different objects. And so here is a quick example of how often I use this in Devouring. This is not even all the times. There's just a bunch more, but like this is compressed of how often I use this framework. And it's just like similar to CyanEmu. It's like without this, we probably wouldn't have gotten as far. But yeah, what the label linker is. Every single project that I said from like my second public world, which was back in Archery mid 2018, like I would just create a one-off, very specialized editor script to do a very like setup thing. And so with the Devouring, knowing how big this project was becoming, I thought I need a generic framework that I don't have to write custom editor scripts to do these little things. I wanted to write something very generic that I could just continue to reuse it over and over again so that I didn't, waste time on new scripts every time. So inside the VRChat SDK, there's something called the VRC label. It is pretty much a useless script. All it is a string that you can just type some message on your component. It doesn't work or do anything inside VRChat. I saw this and thought, I can probably use this as a way of adding multiple tags to objects. And so by doing that, the way my script works is it basically finds all objects of a specific, or all objects with a label, and then finds all objects within that of a specific tag or that string. And then depending on what unique version of the label framework I was having, you do something specific with them. So 2 examples listed up there on what I would use is, one, I created something that's just an event subscriber system. So inside the system, you could basically define, I want an event, I'm going to fire it from some location, and then there's just going to be some random number of objects that are listening to that event. And then this framework will automatically link up everything together, so it's like you don't have to manually drag them around. Another example would be like player tracking. And so we have a way of figuring out where the player's location in the world is, but that's typically a prefab. You don't know how many other prefabs also want to reference that, so it's just made a simple way of automatically finding where those are and setting in the references in the components. And so here's a quick example of setting up what I'm going to call the event subscriber system. Go to this side. One thing that I regret during this project is naming it stupidly. And so I have it called the from object linker and the to object linker. Honestly, that was so confusing because I had to look up the code every single time which one was which, and I just did not rename them. But in this example, we have something that's from object linker, which is saying I want an object to be able to send a message to any other object in the scene. And so I use the label event sender and then just defining 2 random events. So it's like send event 1, send event 2. And then anything that I wanted to listen to these things, I also defined the event receiver, and it has on event 1, on event 2. So my UIs are pretty bad. I did not listen to Orel's talk on how to make pretty UIs, so I'm the only one using this. I guess it's good enough. It works for me for now, but that was kind of one of the issues. Nobody else understood my systems. But going into how to use this, basically you would just define, or at first find an object, you put the VRC label, say what type of thing you were wanting to react to, so this one, event receiver, and then you just add a custom trigger that says send event 1. Leave this blank, it'll automatically be filled, and if whenever you want to send it, you just say on example, have an on interact, activate custom trigger, it'll do this, and then just by doing that, everything that'll listen will receive it. And on this side, we have the receiver, which is, again, adding a VRC label, show event receiver type, and then this will just automatically get called when this event happens. No manually linking anything around. And just by having this system, it kind of made it such that if you had multiple prefabs that you needed to interact with each other, this could just then all be automated by just pressing the button at the top there that just says link objects. And so pretty much every system I built in the Devouring used this, as I've kind of said. It was necessary for making things easier. But then the next major editor script that I had was the scene merge. So as I mentioned, when working collaboratively, we did not want to work on the same scenes because conflicts, and so we could not have one mega scene that did everything, ignoring the fact that Unity couldn't load it all. But so we just split everything up into like these 5 scenes here. We have the basement, floor 2 scene, gas station intro, ground floor, and then the kitchen. Sorry for spoilers there. But because we had all these multiple scenes, VRChat only takes one scene. So at some point, we're going to have to combine them. And then, similar to the previous problem there, you can't reference objects between scenes. How do we fix that? Okay. Use the label linker to assume things will automatically send the messages across. Okay, that's good. And then we could have done our setup where it was just having one time merging it all. Knowing myself, if I have to do it once, I will most likely have to do it twice, so I'm just going to automate the process. And that was where I decided to make a script that literally just takes multiple scenes and merges them together. And then because I'm writing an editor script at this point, I can do other things. So because I know of the label linker and a couple other scripts, I can just automatically call them to do their setups. Because I know of Unity has the baking API, you can just call bake occlusion, and then also baking AI and navigation. There's also a couple other pieces where it's like, depending on it was the debug separate scene or like the combined, some objects need to be enabled or disabled. Example being like a debug light until we've actually baked lighting in there. But yeah, with this is just kind of smoothly made it so that we could combine our scenes and do it multiple times. With this, basically, it was like, once we got to the point where we could merge everything and it was working, we would do a quick merge, play test quickly, and then like after we got all the bugs, we would go back into the original scenes and then just fix them there. Because with the merge, it would just basically be like, 1 minute things are merged, now we can go test. Honestly, it was longer just to upload to VRChat than it was to like combine things. And so it just made it we could keep doing it that way and keep working fast as a collaborative team. And there were a bunch of other editor scripts, but I don't have the time to go into all of them. So just note that those exist, and if I have more time at the end, I can go into it, but not right now. Jesus. So let's go into other things of the actual devouring. One of the separations that I would do is I basically named a collection of things player systems. This was just a giant list of prefabs and giant list of prefabs that kind of interacted with the world and the player. I called it player systems, but it was more than just things that acted for the player. So as I've said before, we need ways to interact with the player, but we don't want to do things over and over again. With SDK2, as I've said, you have to do you can't easily reference other objects. But solution on this: make a giant make prefabs for all the little specific details, and then use my label linker system to reference them everywhere, anywhere in the scene. And so here's a quick list of just a giant thing of prefabs. Thank you to 2018 and nested prefabs. Before we got nested prefabs, it was pretty difficult to update these in the multiple scenes. So it's just, once it became all one prefab and then nested prefabs underneath, it was just, I don't have to work in the main scenes anymore. I can just work with my small set of prefabs, and then everybody got the updates right away. So let's start going into some of the specifics of these player systems. So one of the big pieces of the Devouring was that it was entirely synced for late joiners. And so how we did this was progress tracking. Thankfully, with the event subscriber system, it basically meant we just create events that we want synced, and then you just do buffer one when sending that event. And so that honestly made it pretty easy. You just have to make sure we don't have over buffering, so that it's only buffered once and not multiple times. But you pretty much just send event, and then everybody late joiner just got it. Some of the next systems, health and damage. Very early on, the Kuza was key on saying he wanted it such that players had 2 health points. You get hit once, you get feelings of damage, eventually you'll recover, but if you get hit twice, you're dead. And so with that, that was a requirement for doing damage. We also needed a damage visual, and then saving what actually killed you. How do we solve that one? As with everything in this, I use my label linker to define the events. So the events down there at the bottom were saying damage player or kill instantly, and then other was maybe people may not have noticed this one as much, but when you got seen by the lurker, you would visually get hurt, but you weren't actually damaged. And then the last being killed by X, and then X being, was it the 8 different ways you could die in the game? And then at the top there's just a quick animator system of what actually happened. It's just kind of simple cycle of, okay, you're hurt, It shows hurting and then goes back off and then back off. And if you get hit twice, you just died. Funny story about that. One piece of that the Kuza developed towards the end, where it was the mannequin chase. He managed to time it perfectly to break my animator. So it's like, thank you, Lakuza, for doing that. But at the same time, how did you manage to do it so perfectly? And yeah, he like found the exact timing it would go between this transition and hit you again, and then it just kind of like everything looked odd for a moment, and just like a couple of weeks, it was just being like, "Have you fixed this yet? What is going on?" I'll get to it. Let's go into one of the next systems. Has it reset there? There we go. So in the world, we have a bunch of different things going on. Some things are global that everybody sees, other things are local. Example being the basement. The basement itself was mostly local, so the water ghost as well as breaking doors, only you saw those things happen. And so whenever you died, they would reset. So we would need we needed a way to basically automatically go back through and make sure those things reset when you died. As I keep saying, this was basically just an event in my label linker system, just reset on death. And then one of the other pieces to that was, thanks to other weird bugs that who knows what caused them? Maybe bugs on us, bugs on VRChat, we don't know. Things needed to be reset because they would sometimes break. Well, VRChat is known for jank just because nobody knows how to do everything, but, you know, we're learning these things too. So with that, whenever you died, and as well as whenever you respawned, we would just make sure to reset a bunch of things so that they were back to a default state when you came back to the spawn room. One of the big things that would actually break is our area detection, like the sounds. And so from that, like, sometimes you might hear wrong music when you're not expecting it. And so it's just kind of colliders being weird. Just whenever you respawn, that would reset to you're now in the spawn room, all those values are back to normal. And so one of the pieces on there is the reset if needed. Basically, since there's so many different actions that would happen when you reset, I had to make it such that, you know, only reset the things that were triggered during that event. And so, thankfully, custom triggers will only activate if the thing was enabled, though you can just have a giant list of them, and if they're not enabled, it doesn't do anything. But then if you activate them, then or activate whatever the system was, you can then activate the custom trigger, and then it's just like, oh, this needs to be reset, it'll automatically call it. Going into the next system, fading. So one of the jarring things about most of VRChat worlds, because this is not provided as an API, which is fine, I guess, but is when you teleport around, it's pretty instant and jarring. So one of the things we wanted is we want to smoothly transition you from one location to another. How do we do that? Solve that? Just put a bucket on your head. So it's just a black box with a higher render queue, so it's like renders over everything and it fades in and out. With a simple animator there. Now, some of you might be thinking, why didn't you just use post-processing? It would be super simple. You can just animate that instead of putting a bucket on people's heads. And I'm going to say, I don't like it when people use post-processing because it actually blocks your menu. And I don't trust my own systems, so if it happens to break in such, you know, you're stuck in fog, you can't exit the game. Yeah, so I don't recommend using post-processing to black out the screen. Use...
What? No post-processing.
Yeah, that's a solution, but then you don't have the world. But yes. One of the next things, we wanted to add fog to the world, but we also didn't want the fog to be constant. So how do we do that in SDK2 when you can't even control fog? You can just have it enabled or not. Well, the solution to this, thankfully talking with the shader people, you can just enable the depth buffer with a custom light with shadows enabled, not set to anything. And then using that, I modified one of Silent's fake light shaders to like read the depth, and now you can just see how far an object is from the camera, and then just say color to pixel, or set it a color based on that depth, and now you have fog. And so with this, you can then animate the distance, and that's how you get fog in SDK2, which there was one portion where we really needed to animate it, but I don't know if we needed it other than that. Still, thank you all the shader people helping with, you know, learning shaders. So in the Devouring, there were multiple spawn points. We kind of had to move you around in different areas. You start at the gas station, and then all of a sudden, you know, you crash your car and you end up in the manor. And then everybody ends up in their own individualized spawn. And then once you start leaving the manor, there's different spawn points after that. every scene was a different, or sorry, like each of those portions were from a different scene, so we needed to make sure that we could easily link up all the spawns. So thanks to the label linker framework, I just created a specific one that's just like create a spawn moving piece, and then that location of the game object would then become a spawn point after you set the trigger, or called the trigger. And so with this, I set the label linker based on each spawn point. All the scenes would link up, and it would automatically move whatever the spawn point is around. And so, as I mentioned, when you enter the manor, your spawn point is set based off our different location, and that is just based off which chair you were in when you were driving the car. Player mods. So one thing that we knew early on, we were just basically comparing things to, I guess, Amnesia, but they had a water section. I don't remember, or I don't think they had slowing down, but we wanted to change it up a little. So it's like when you got into our water sections, we wanted you to feel more in danger. You wanted to be slowed down. And so before the Devouring started, nobody knew how to change mods. And so that was kind of a problem. Thankfully, while working on it, I realized you could just change the player mods by just having another set of them and having it entirely local. Like, how many years had it gone by and nobody just tried this correctly? I don't understand how that worked out. But we had multiple things that we wanted to change the spawn, or change the mods in the world as well. Like, yeah. When you have to change mods, unlike Udon, where you can just set the jump speed or set the walk speed, like you have to basically set all your combinations at once. And so, as you can see in the picture there's just a bunch of different settings. And like with slowing players, like in the water, you had to count how many colliders there are to make sure you should be slowed or not. But one funny thing about this is before I knew you could use player mods, I was going to get players slowing in no matter what. So I think I showed a prototype to the other people on this, where it's like, whenever you're in the water, I was using some janky player-based tracking shenanigans to this, force your position around, which would then allow me to either speed you up or slow you down. I'm really glad I didn't have to do that, because I'm assuming that would be actually kind of costly, which the Devouring had issues with that. But yeah, moving on. Area management. So, going through the Devouring, obviously we have different music depending on what area you're in. The Legends made amazing soundtracks, so we obviously had to show it off, or play it off. And so the way we ended up doing that was just having a giant colliders around each individual area, and a giant animator that said, in this area specifically, you play this sound and you play this post-processing. And then you just kind of animate either the wait for post-processing, or you just animate the volume down for when you're in or out of the area. It made it somewhat easier, and I think Lakuza had said he did something similar with this on his previous worlds too. The next one. So this is overall a larger system, which is just kind of vague, but when you're in the Devouring, to make it, or as a stretch goal, we wanted to make it more immersive. So we have multiple things that happen to players, but initially they were all local and kind of did not make sense when other players, or it happened to other players. Example being, when somebody died, obviously you would see your own, fading in as you got teleported back, but at the same time, the other players would just see you vanish. So one of the things that I requested was we need particle effects to notify people when they die. So Fiona made particle effects when they died, and then I put those in as something called prop spawner. If you want to show something synced per player, you basically, in SDK2, would either need an object pool, which would never made a successful solution, or just spawn each object in per player. So Hardlight made something originally called prop spawner. I then made an update to it, which just kind of simplified some logic. And then using that system, we were able to spawn in synced immersive items to the world. So particles when people died, as well as particles when you entered the water, so the splashing and the waiting sounds. And then also when somebody is being stalked, and you could just point at somebody and be like, hey, move, move, move. And so that really helped with the immersion of the world. But prop spawner itself is kind of complicated. So with spawned objects, thankfully scene spawned objects can reference things outside of them, but nothing can reference inside them. So that kind of was an issue of how do you communicate with the spawned object, what's going on. So with this, all the way back from Funhouse in 2018, I realized that you can use UI buttons to basically make a dynamic event subscriber system inside your world. I wouldn't say it's the most performant, but it works. So what you can do is you can use a UI button, just define this as what you want to have happened, reparent this under a game object, typically a completely empty one, and then use another game object or button to call broadcast message press. This will go through every child of that game object and send the press event, which, because we have a UI button, that would then send the message to do that action. Which, since spawned objects can see things in the scene but nothing can see it, you can reparent something out of it, and then now you have the ability to like send any event or information you want into the spawned objects. So that made it, well, as you can see on the image there, it's pretty tedious, like setting up all the different events that you would actually show for each spawned object, but it worked out because, you know, we added the immersion there. So with the Devouring, this is a massive world. I make complicated systems. I needed a way to debug them. And so I pretty much always had my own version of a debug menu that I can access in both VR or desktop that's just kind of showing different things. And so with this one, I wanted to basically be able to see the different debug visuals of like what's the systems that I've made. I think at one point we didn't have lighting, and so it's just like, okay, now we need a headlight. There's other times that you want to test things and you don't want to die. Or you just don't want to see monsters overall because we, you know, want Fiona to stop screaming and actually take notes. There are other pieces to this where it's just kind of in the basement sections. We were doing modular assets. We had floating point issues and there were a ton of gaps. So I made a quick shader that just showed the depth, which basically made it as a gap finder. And so it's like if you saw something that was pure white, obviously there was a gap between a wall. And then teleporting around the manor so that you don't actually need to solve the 3-hour puzzle. You can just teleport to some location, solve that piece, and then move on. For performance testing, see the FPS, because just opening your menu would actually drop your FPS, so it's like not the greatest solution there. This was all before I had downloaded FPS VR, but made it so that anybody could see it. And then Lurker, being the most difficult thing to debug, added a simple button to just be like, hey, break. Yeah. So here is a quick example of what the debug view looked like. I'm assuming no one here would actually understand it or want to see this because this is just something that I understand. But there's a bunch of dots and lines representing all the different systems. So you can see the red line and the red dot there representing both the Lurker and where the Lurker is going. There's a lot of green dots littered around in this image that's just representing where every journal location is. So when testing testing if all the journal collects work, it would just be like, oh, there's a dot over there, we missed that one. With prop spawner and the stalker being synced, then it's just kind of like, well, where's your stalker? And that's what this, let's see, pink oval here is. Yeah, there's a bunch of different systems, and what I was just showing through that one. I assume no one else would really understand it, and I don't even know how much they used it. But moving on, different enemy systems within the Devouring. So the first one was probably the simplest, just the Living Darkness. What do we need to do with the Living Darkness? We basically need it so that when players got near, they were slowed down. When players got too close, they died. We wanted to make it, visually interesting, and then also we can make it appear and disappear, just because we have the light puzzle. So with slowing down and death, obviously continue using my label linkers event subscriber system. And then for making it look interesting, because I was messing with silence fake lights, I kind of just continued doing that. I just made a dark blob. But then as we added Shishi's volumetric god rays, we found out that because the fake light didn't write to the depth didn't have a depth pass, it would become invisible when you saw the god rays, and so that was a problem. So to solve that, I basically added just a simple vertex wiggling shader on a sphere so that you could just see what is the core of the Living Darkness. And then for growing or disappearing, appearing and disappearing, is just an animator for making it increase in size and decrease. One of the next enemies within the Devouring was the Water Ghost. So the requirements there being just an NPC that follows the player. It can break doors. It can also was unsynced, thankfully. So how do we solve that one? Basically, just take the AI third-person controller from standard assets, delete the Ethan avatar in there, and then add water particle visuals that Fiona drew herself. And so following the player, just targeting the player tracker. There are some bugs with that specifically, so it just pretty much ignored the Y component because otherwise it couldn't find paths. And then for detecting breaking doors, it's just kind of having on enter triggers and special colliders. So, yeah. Okay, the Lurker. Probably the hardest thing to explain, but also an extremely complicated system here. What are the requirements on that? An NPC that patrols the set path. People have done that before. It detects and traces players and finds the closest. People love to request how to do that in the official Discord. Players can escape its view, and then, this lurker would like to search the area when it loses sight of it, which was a stretch goal, and then hopefully is optimized and is also synced. Yeah, that took a lot of work, so honestly the solution is just kind of, it's magic, hand waviness. I'll start breaking down the problems. Lurker patrolling around. So the requirements there, we wanted it to follow different waypoints. We needed to have different search animations when it reached a waypoint, and then when, say, it was chasing a player, it needed to be able to rejoin the waypoint system. So similar to the Water Ghost, just take the AI third-person controller, replace Ethan with a custom mesh that Lakuza had made, and then also custom animations Lakuza made. And then for detecting waypoints, I did not use the standard asset waypoint circuit because that does not sync for late joiners. I had to end up writing my own system for this, using the label linker as with everything else. So I basically made a label linker system that was just kind of given a list of transforms, basically link them together so that on enter trigger for one, you would then move some object which was considered the target to the next one in the list. And then it just kept doing that, and then it would cycle back up to the top. And so also having that being the label linker, I could then say target the lurker and say play a specific animation or not. So the lurker itself had two different, searching animations. One being just the standard look around like this, and then the other just being like, I'm going to break my neck. So I assume a lot of the speedrunners hated the breaking their neck ones. One other thing that was not as obvious, I don't know how many people actually noticed this, but depending on how big the area the lurker was walking around in, it would actually change its walking animation. And so we just had different area colliders that would just say, in this area you're going to be standing up or upright, and then when you get to an open area you're going to swim around as a ghost. And so you can see the animator for that there, where it's just kind of the top one being detecting checkpoints, and then the bottom one being how am I currently walking. And so the next thing with the lurker is, how do you sync the position? Well, syncing AI is difficult. Hardlight tried doing it once with his toy box, but one thing that I found too annoying was that it ended up being really jittery. So why is syncing AI difficult? Well, the AI third-person controller prefab and all that from standard assets was never meant to be synced. It's not meant to be, or it's not even meant to work in VRChat in the first place. The way that it is just kind of it takes the object and it always heads towards the path. Does not matter anything else. With VRChat, if we want it synced, obviously we need to have an owner. And if you have an owner, you pretty much only want that owner to move that object. And so if you want the AI script to also animate, the scripts need to be enabled. So Hardlight's solution was pretty much every 1 second, you move the AI to a synced object. By doing this and network latency and all this other stuff, it would always slightly be off path for the non-owners, and you would just kind of snap back to place. That does not work for fast-moving AI, and it does not work for combat AI. So how do we fix that? One of the things that I found out doing my massive tests of walking Freds is that object sync updates, or object sync sets the position on the update loop. Okay, if we have it on the update loop, that means we can use the late update to then mess with its position, and it won't be messed with because of object sync. AutoCam has the ability to use late update, and so if you pretty much just put AutoCam, or basically remake Hardlight's lock sync system, but using AutoCam instead of the periodic resetting, it just kind of works. And so that was one of the things that I found was really great to have for syncing AI, because it just kind of solved a bunch of problems. I can go into more detail on that, probably have a different talk, but it ended up being complicated. Syncing AI is not as complicated as it is or was before. But what could be considered complicated is detecting players. So with the requirements on this one, we wanted the lurker to detect where the players are in the world. We wanted to basically we wanted it to occlude their vision when they're behind large objects, and then we also wanted it such that small objects did not occlude their vision, like the standard amnesia bug where you put a book on your face and then it's oh, I can't see you anymore. Okay. So the easy solutions here, using raycasting with standard assets to detect camera from wall clipping. This now gives us the ability to find and go through our search an area and hit objects and not go through them. Using look at target, you can now get a range division, and then in order to bypass the whole like book thing, you then, or I basically made it so that the Lurker looks at 3 points on the player, so their camera and then just slightly below their camera. So it's like we didn't have any object in the world that was specifically that size, so you could never get blocked. And then obviously on detected, the Lurker would change its target to you. And well, how do you sync or which player is being targeted? Yeah, so the goal here was to make it such that it targeted the closest player and prevent constant ownership transfer. This is really where I say like the magic comes in, because like I'm kind of amazed that the solution that I wrote actually worked in SDK2. Like there's so few ownership related things that we can deal with that it's just kind of like, how did this work? So the basic idea was kind of like, if you were the first person spotted by the Lurker and nobody else had been spotted, you pretty much just take ownership immediately. If you were not the first person, then there's kind of this like weird network latency like check that's just like, okay, I'm spotted, somebody else is spotted, let's wait and see who actually gets spotted again the first time. And somehow it ended up like backing off properly, and so that it didn't just constantly take ownership back and forth, because I believe I put in a delay of at most 1 or 2 seconds there. But that's really difficult to go in actual detail. Just showing this animation isn't even all the different things that went into it. So it's like, as I said before, hand wavy magic. This is the problem that, you know, Udon is supposed to solve. Okay, the Lurker itself was not very performant. It's one of the things during the optimization phase is like we had to update things, like there was, in the beginning of the Devouring, the Lurker was not enabled, but at the end, 2 of them were enabled, and it's like, I could definitely see that in the profiler. How do you improve the performance? Basically, the AI scripts, you just kind of turn them off and update them 3 times per second. You don't need them happening 90 times per second, especially since it has some things that were not the most optimized. So basically, AI pathfinding, update it 3 times per second. Same with player raycasting and targeting position. And so that helped with that. Also, I think there was like 5 different animators at one point, which I just had to like merge most of them, which that's a piece I'll get towards the end. I'm not sure how much I have on time on this, so I'll just go ahead and skip that one. But the last enemy system that we had in the Devouring that I worked on specifically was the Stalker. And so with that, going with the requirements, early on we had the idea of just like, wouldn't it be funny if we forced the players to keep moving? And then like, you know, the anti-streamer enemy. So we kept on the idea like players needed to move, they were never allowed to be stationary for too long, and as a stretch goal, everybody could see why they had to keep moving. So with this, we came up, or I guess at that point it's been like 6 months, because then Climbing It came out, so we had player-based tracking, and so we knew exactly where each player was in SDK2. Using that, we can move a collider there, and then basically say, is the player in this current location? If the player is, let's time how long they're still in this location. Using an animator, we got the timing for it. And then once, you know, the player's been there for 15 seconds, we basically say, cool, play an animation of the like stalker tentacles coming up to kill you. And then all of that happens locally, and just when we wanted to sync it, it just basically move the animators to a spawn, or move the visuals to a spawned object, and then now everybody can see when you are being stalked. So that's pretty much the enemies. Let's go into other systems within the world. The first one being anti-cheat. So in VRChat, there's kind of like, you know, when playing adventure maps, we can't really control what the player does. Everybody has play space, so they can move around. And so in order to prevent the dumb situation of, you know, I'm just gonna, you know, peek through a wall and see what's happening, or like I'm gonna unlock a door. So in the Devouring, we had our doors so that they were locked only from one side. And so to prevent it just being, you know, I stick my head through and then click or something and it would unlock, we basically set it up so that you had to go through a chain of different things to unlock that door. So in this example here, we have the door that is right outside the spawn room. You basically had to enter the hallway from the other corner before you could actually unlock the door. And so that helped us, you know, keep people from cheating as much. And so one of the other things is that since player colliders exist and are terrible, we basically had to add our own like proxy collider that's just like look for our collider and not just any avatar collider, because as somebody did in Lakuza's Discord, somebody literally had a collider that was the entire world and they just unlocked a bunch of weird things. And that was a weird playtest from their pictures. But yeah. one of the other systems that I had to devise is like, how do you detect when a pickup is in at a special location? So in the Devouring, we had keys, we had like special puzzle blocks, and then roadblock coins to be able to open doors. Well, the way that SDK2 normally solves this is like, you have on enter trigger looking for a layer. That is typically not enough, especially in the Devouring. I think we probably had like 15 or 20 key objects. We only have like 10 custom layers, and like we were using them for other things. So how do we get past that? We have to use something called lifted colliders. I wrote the secondary VRChat wiki article on this, so if anybody wants to actually look up how it is, because I can't explain it in timing here, it's just kind of like, instead of using the layer, you kind of just like duplicate your world in height-wise, and that height now becomes like your key. Weird explanation, something about balloons. So that gets pretty tedious to actually write it out. So I just wrote a script with a super bad UI, and that would just generate all the like detection for pickups automatically. And so there was a ton of different options on there, obviously being like making it such that it didn't have to be enabled at start. You can then detect when something entered, when something left. Yeah. So originally I wrote this script and it was not responsive because it was detected only when master moved the object there, and Lakuza would always be the master during our playtest, and since Lakuza has the highest ping, it basically meant if I moved an object to its key location, it would be half a second before it detected, and it's like, yeah, that was a terrible experience. I pretty much had to take, I think, 2 weeks to just like rewrite the system to be entirely local, to generate all entirely local stuff. The next system was water slowing. So I mentioned earlier that we can have player mods to slow down the player that way, but then how do you detect when the player's in the water? Thankfully, we can use onEnter trigger, we can detect when an avatar collider is in the water, and then we can use a counter for every time it is, and then, like I said, using label linker to go into player mods and say like, hey, players in the water, change your speed. One thing to note, avatar colliders make me cry. There was a bug, or actually still is a bug, in Unity itself. If you delete or turn off a collider, on exit trigger does not fire. This meant if you were in the water and you changed avatars, your avatar collider was happened to like be turned off or destroyed, and we literally have no way to detect that. So that was a problem that I had to figure out, like agonizing over a month or so. The dumb solution that I ended up writing was just kind of like, depending on where you are, I just put an enter trigger saying that when you go to this, your water or mod setting just reset. And so, yeah, just don't even solve the problem, just kind of reset your current status. But that's definitely one thing that I don't know a proper solution, since I think it's an issue with Unity itself. So one of the next systems, player splashing. This was one of the stretch goals that I had for like so long. It was just kind of in the last portion of the basement, like there's that giant fall. Every time we did a playtest, I'm like, I want to hear a splash, and there's nothing. And it was just so disappointing. And so I think one day I got fed up with it. I didn't even tell the others I was doing this. It's just like, I'm getting player splashes and I'm sinking this. And so what do you need for, or what were the requirements? Basically, whenever the player jumps into water, they can't just walk into it. They had to jump and land inside it. They would play a splash. And then whenever they walked around in the water, it would do a little waking sound. And then obviously I wanted it synced. Well, we said in the previous slide, you know, we could use water detection of when they're in the water, and then we can use area colliders to know where, like, the height of the water would be for this object that is the splashing. And then what's odd, I guess, is the player speed detector. In SDK2, we obviously don't know the player speed, but thankfully all I needed to know is, are they walking or are they jumping? And so that just ended up being just a simple, is the player moving fast enough for another object that is moving slowly to exit a collider? And if it is, cool, they're moving. And then, as I said earlier, using prop spawner to make it synced. So that was how splashing came to be, and I guess was probably one of the satisfying things to constantly see in every playtest. Basement colliders. Okay, so if you thought the basement was difficult, imagine if every time you tried to jump on a box, you failed 50% of the time. All of our playtesters, like all 5 instances of those, like just the basement was terrible. So I was trying to think, what is the best solution to fix this? Is like, I just looked at the problem, said obviously the ones that you want to jump on are the ones that are kind of like tilted in the water, and I wrote a script that basically said find every box that intersects the water layer and just add a little capsule collider at the floor so that you walk up them and like instead of needing to jump. So the entire basement, you don't need to jump at all. You can just walk the entire way through. It's like, this is probably one of those little things that nobody would have noticed, but like, it changed the difficulty of the basement, making it easier, even though it's still extremely difficult. So yeah, be glad you didn't have to deal with how difficult that was before. So there's not much time, so I'll kind of like speed through some of the other slides here, but how do you sync things with SDK2? Well, for one, thanks to CyanEmu, download this if you haven't, I had a system where you can actually go through your world and test how buffering works. So the example with this, just play through it. Obviously you have to play through all of it. It'll go through, and every time there's a buffer trigger, it'll save that into a queue, and then you can click this button that says Save Buffer Triggers, and once you do that, you can exit out of play mode, click the, I guess, other button up that top there that says like replay them, and then start Unity, or start play. When you do this, it'll just go through all the triggers again and just play, execute them in order that they were the first time. This follows along with buffer 1 versus always. And so, thanks to that, the Devouring easily was synced properly for late joiners. The difficulty, though, is I don't know if my implementation is exactly like VRChat, so there's definitely some timing things, because I know when my implementation is all in one frame, where VRChat's is not. But good enough to help me from debugging things. But now, going along with what is buffering, we have pretty much two options, buffer 1 and always. So one of the key things when you're doing buffering, though, is you typically don't want a delay, because if you do add a delay, that just breaks the order of operations of when things happen. That's not enough really to explain what that means exactly, but yeah. Typically ignore adding delays when doing buffering. But now, when you choose between buffer 1 versus always, you would basically want to choose buffer 1 when it's a very explicit action. So if I'm going to set an object to true, true being explicit, you want to use buffer 1. And if you ever want to undo that option, or undo that action, you would have another event that says set game object false, also buffer 1. And those two would then cancel each other out. And so that just equalizes there. Now, whenever you want to use always, it's just only for counting things. Technically, you could use toggle for this one, but I would say rewrite your code to be explicit true or false instead. But in the Devouring, as an example, we had the ending counters for like the journal, as well as how many what are they called, collectibles that you found. So with that, we had to always buffer all the animation ints. And more on buffering, buffer 1 may not be enough. If you're trying to buffer or late joiner sync an animation without fully syncing the animation with that component, you basically need to also have a jump state to the end. And so, as this example here is, we wanted it for the timer in the basement, that when you solved the timer, we did not want it to ever happen again, but we still buffered the event of, the lever going up or down. And so, we added a trigger that would buffer the completion, but if you look at the animation states, if we didn't have this jump to the end here, it would still have to go through these states. And so, if you're going to buffer these kind of animations, you will need to jump to the end. How much time do I have left here? So quickly go over some of the optimization things that we found in the Devouring itself. We basically had a lot of culling issues. How do we end up dealing with culling, or occlusion culling? Basically add large cubes everywhere. So in this picture, you see the pink boxes. That's how we ended up culling our objects in the basement. A lot of the modular assets did not set to what's called occluder static, because they didn't block everything properly. So we had to use specific cubes, and that just honestly is how we've been dealing with that and making it easier. When designing worlds, though, always think about occlusion when you're designing things. So this example here in the second floor, after the first portion of the Living Darkness, this hallway used to go all the way across. And so if you were standing in the corner, which is kind of like off here, like you can't see though, you would be able to see like this entire area rendering as well as all of this area rendering, because there was nothing occluding it. So we had to go back into the design phase and basically say like, just break up this hallway. There's like 3 other, or maybe more locations in the Devouring where we just had to completely change the layout there. So think of occlusion and what things, like what lines you'll have on like what things should be rendered. In 2018, though, occlusion is kind of broken in Unity. So it's like, Lakuza spent like a month on this bug, and it was so frustrating. Of just like, Yeah, when you were in VR, only VR, not desktop, if you find the boundary between two occlusion areas, it would basically blink everything in and out of existence. It's like, we couldn't solve that. It's just a bug. It exists in the Devouring. It also exists in a bunch of other worlds. Hopefully, when switching to like 2019, we can get rid of that. Profiler. Yeah, I spent a lot of time in the profiler towards the end of the Devouring, but yeah, you want good frame rate. Frame rate is basically just saying like how much time does each frame take. You want 90 frames per second, which is about 11 milliseconds per frame. If it goes over that, obviously you drop frames. And so we don't have all that time in VRChat because, you know, our systems are the only ones running. So we need to minimize our impact during Devouring, or just like our world itself. And so I show an example of what the profiler will like give you back. And it'll also show these two slides, or two pictures. The top one being the default view, which I believe is called the timeline. This can be helpful for some people. I always switch it to immediately hierarchy, and you can see kind of like what every method call is and how long it takes. As an example, you can see how inefficient my CyanEmu is, and it's just like, you know, if that thing's taking like 0.21 of a millisecond, yeah, I gotta improve that. But just going through that, you can then see like, all the things that were taking place. Now, this being SDK2, we don't have custom scripting. It's still kind of like, why would you use the profiler? Well, remember that slide that I said, like, how many different objects we had? We had basically we had 800 animators, 2,000 audio sources, and I think there was also, like, 500 particle systems. Skipping this slide here, reading all of that, actually, you can actually see the data up here. Yeah, 500 particle systems, but, like, using all of that, it actually caused a massive performance decrease, just those doing absolutely nothing. And so that's where I basically said, we need to make everything event-driven. If it has any form of update loop, doesn't matter, turn it off if it's not being used. So every animator, audio source, and particle system that was not active in use, we turned it off and waited. And so we had so many chests of drawers and things that were just kind of like sitting there waiting for players to interact. We basically had to rewrite our systems in the last month that was just basically make them event-driven. So turn off the animators when they're not being used. When you interact, it turns on the animator, does the animation, and then turns itself back off. And so that was a fun time because I believe that, you know, that saved like 2 milliseconds or more just turning off animators. That was a fun time there. Let's see. I think there's more editor scripts, but I don't really have time, so I'm just going to go ahead and end it here and say, tell me your questions. I assume that was a very heavy talk. I don't know how much of that you could actually like use, but hopefully you got something from it.
So good.
We have time for like 2 questions max because we already...
Yeah, I realize.
I mean, this is CyanLaser we're talking about, and like, you know, everybody knows where to find him, I think. So it's I don't.
Yeah, ping me on Discord if you have actual questions after this too.
Find me. I can ask if we.
Who's the first one in line over here? Do you have that enabled?
I mean, I have the thing
It's,
enabled, so anybody who
yeah,
can. Oxy's just dead over there.
9 if you want.
So you were talking earlier about how it's hard to work around the fact that when you change an avatar, it deletes your collider for a minute, and when you slow down and you walk through the water. Would it be possible to instead have that system rely on an outside object that is set to track the player locally?
So, yes, you can in theory track the player locally, like using player-based tracking, but player-based tracking is pretty janky. I could have used it to get the bottom of their player. So it's like, we had a proxy collider already in there, which was basically tracking the player's head. I didn't want to use that for water specifically because then I would have to track the player's base because I have to track the player's foot. And so players' feet are, you know, different height, and then it's just kind of, I don't know how much of the performance impact of doing player-based tracking every single frame. And so, like, that's the reason I tried to avoid that, because, like, I already knew this was a pretty heavy world.
Okay.
So, does that
Thank you.
pretty much answer your question? Like, in a less impactful world, yes, you could have done it.
Got the thing.
I'm gonna go if no one else goes. Alright, here we go. Hi, Cyan. This is gonna be, given the amount of time you have left, probably a bad question, I'm gonna try anyways. Given the toolkits and the tool chains that you've developed for SDK2 and triggers, it's really interesting, especially from a perspective of a developer for VRChat, that like, you know, SDK2 you've done. This is easily probably the most complex SDK2 world we'll ever have. Period. Full stop. However, given that you've developed these toolkits and you've made some or all of them available, how do you see this affecting the creation of SDK2 worlds versus people migrating to SDK3 and Udon? Just your personal opinion.
So my personal opinion, as Udon is right now, it is not simple enough for people who are not programmers. So SDK2 will continually be used until that alternative of making it easy to use in Udon. So with that, I just assume SDK2 will continue to exist, and then these kind of things will just make it easier. So really, it's just like, until everything that I did in SDK2 is as simple to do in SDK3, I don't expect people to move immediately to SDK3.